All right, here we are today, video 15. We're going to be talking about internal validity. Internal validity is one of the big deals in research design. What you want to do is construct your study so that what your results are reflect what you are actually studying. The validity of your experiment is in question. And so that's what internal validity is about. It's how much your evidence, in other words, your results, actually supports the relationship that you hypothesized. And so this is true for both association and for causal studies. It seems to be more of a thing for causal studies because there are more ways in which causal studies can fall apart. But you also want to make sure that with association studies, your correlation is because of the two variables that you're looking at and not some other thing. So really this is about how much your evidence supports a causal interpretation or an association relationship that you hypothesize. How much are you confident that your proposed relationship wasn't influenced by some other variable, or how much your study design accurately reflects what you observed? Those are all ways to talk about what is internal validity. And so here are a list of threats. We've got a bunch of slides. We're just going to go one by one in terms of threats to internal validity. My suggestion is that as you go through this video, that for each slide you pause and then you think about your study and you think, does this apply to my study somehow? And then you unpause and go to the next threat. That way, I think that's just more efficient. You could listen to this and then take notes and then listen to it again, and the third or fourth time think about your study. I think let's just do it all at once and pause. Okay. So the third variable problem, we've talked about this a little bit before, you read about it. This is where the relationship between your variables may actually be due to some other variable. It could be a correlation, it could be a causal thing. So one example is there seems to be a relationship between sales of air conditioners and drowning. So you would say, oh my gosh, every time our sales and air conditioners go up, there are more drownings that happen. Oh no, it's air conditioner sales. When actually the third variable is the fact that it's summer. It's getting hot, so more people are swimming, more people are wanting air conditioners. There are a whole list of other things to check. These are all different internal validity problems. So the problem of history. This is where something happens that's unrelated to your study, but that's what actually creates the change in your outcome. And so kind of thinking about the previous example where it got warmer, and that's why you had air conditioner sales plus drownings. Here is an example where history creates the change. You might think of history as time passing. It got warmer. And so you did your study in March, April, May, and June. And so in March, people were more depressed because it was cold. And in June, they were so happy because they were outside and it was warm and they loved it. And it had nothing to do with your intervention. So maybe they're exercising, but the exercise didn't make the difference. What made the difference was June. Or maybe another example is school ended. And so they're going along and they're giving you their measure of stress. And then all of a sudden school ends, and the last 2 weeks, there's like no stress at all. And you're like, see, I told you that reading the meditations of Marcus Aurelius would help. And they're like, it had nothing to do with reading meditations. It was because school ended. Okay, next, maturation. Here your participants get older. They mature. They might get over some things. Things might not be the issues that they used to be. For example, they overcame their panic about living alone simply because they got older, they got mature, they got used to it, something like that. Sometimes you can look at this like it's what they call a practice effect, so that they practice it enough so they got better at it. So it wasn't really a thing anymore. Instrumentation. This is where, for some reason, you use different measurements in the pre and the post test. I don't know why somebody would do that, but I guess sometimes people have done it enough so that this is now on the list of things to check for internal validity. So for example, let's say you measure depression in the pretest with the Beck Depression Inventory, the BDI. But then at the post-test, you decide that you want to measure it with the Hamilton. And so then you have two different measures in the pre and the post-test, and instrumentation may create some of the problems. You're not comparing apples to apples. Testing effects. Sometimes people figure out their results in the pretest and this affects them. So let's say they took a pretest and they figured out that they were really depressed. And they're like, oh no, I had no idea I was so depressed. This is terrible. And now their post-test score is higher because they're so discouraged. So that would be like a testing effect. Control group effects. Maybe your control group was actually not a neutral control group. Maybe there's something going on with your control group that didn't happen in the treatment group. So there was some effect of being in the control group. So for example, maybe you said, okay, so the treatment group gets the treatment and the control group just waits in a room together. Well, what if they're waiting in a room and some people in the control group like have a party and everyone joins in, or they bring out a card game, or they have such a great time that now the control group is having some sort of a treatment. Or maybe the control group was somebody you put on a wait list and they were like mad they had to wait. So now there's something different going on with the control group. Or maybe the researchers treated the control group differently. Maybe the researchers felt so guilty about having these people wait that they ended up giving them out candy, and so that made them happy. Selection bias is another thing to check. What if your two groups aren't equal at the beginning of the study? So this is where you always want to check that with running those comparison tests where you're looking to see if they're the same. Are they the same in terms of their level of depression at the beginning of the study, for example, or their level of happiness, or their level of grades, or their education, or their age, or whatever your basic variables are? You want to make sure that the groups are equal at the beginning. So let's say an example is you ask people to volunteer for when they wanted treatment. And so the people who volunteered for the treatment first were maybe the people who were more upset and depressed than the people who volunteered for treatment second. So that might be a difference between your two groups. That would be a selection bias. Or this is actually an example from real life. I worked with a researcher who set up a study where she recruited patients from the Monday and Wednesday surgeries to be in group 1, and the patients who were in the Tuesday, Thursday surgeries were going to be in group 2, which might have been okay if they ran the same surgeries on all of those days. But no, there were different doctors in the OR and they did different kinds of surgeries. And so the patients from Tuesday and Thursday, for example, had surgeries that were a lot more complicated than the patients on Monday and Wednesday. And so, of course, the patients on Monday and Wednesday, their problems were easier to fix than the other patients. And so her groups were not equal at the beginning. Attrition is another issue that you need to check. Maybe enough people dropped out of your study so that the only ones left, either there was some sort of bias operating or you can't analyze them with confidence. Maybe the only people that stuck with it in your study were people that had a personality was like, no, I'm going to stick with it. And maybe that's what's responsible for your outcome. Or maybe you ended up with 4 people and you can't analyze that. Regression to the mean. This thing to check is about how when you sometimes take a baseline measure or baseline score on something, you have people who just like by chance score kind of out of bounds maybe, and so their score might be unnaturally high and it might have just been chance that made it high. And so the next time you measure it, no matter what, it's going to be closer to the mean. And so it being closer to the mean just has to do with, well, this is the next time I'm measuring it because what I got the first time was an anomaly. And so now I'm getting it closer to the mean, but that's not because of treatment. It's just because that was an anomaly. So cholesterol is an example. Let's say you measure somebody's cholesterol and it just happens to be really high or really low that particular day. Because, you know, when you measure cholesterol, your measurement doesn't give you an average. It gives you what your cholesterol is today. And what if it's like kind of an anomaly? It's changed up today more than usual. So people say, oh, my cholesterol is like 220, and that's what it is. And they think it's 220 all the time, when it was really 220 on the day you went for the test. And what if most of the time it's like 175? Or, maybe there's probably not that much variability in cholesterol, but in fact, there certainly isn't. But there might be that some of those scores are a little bit out of bounds because it's an anomaly. And then when you measure them again, that movement is not due to your intervention. It's just due to the fact that that score was an anomaly. You can fix this using random assignment for your groups, or probably in a better way, you can just use multiple measures. And so you might say, we want your cholesterol score pre-study. And so we're going to ask you to do it on Monday and on Wednesday and on Saturday. And so now you get, that's a little over thorough, but maybe that'll work. So you get 3 different cholesterol measurements on Monday, Wednesday, and Saturday, and you take the average of those. Or maybe one of those cholesterol measurements, like maybe it's the Wednesday one, is really high. And so you're like, wow, that's something happened. That was an anomaly. We're going to throw that out and just use the average of Monday and Saturday. More things to check are listed in Chapter 5 on page 122. And so I would suggest you look over those. Some of those we have already talked about today. There are other ones. Wow, I've missed effects. I'm typing this so fast, I apologize. Experimenter effects are one. Social desirability, Hawthorne effect, Orr effects. Those are all listed in your book and in the chapter. And so make sure you look at those as well when you're doing a check for internal validity. And so while you've listened to this video, hopefully you've paused and thought about your study and if any of these things to check apply to you. And then you can write your list of what are the things that might be threats to internal validity for your study, or what are the strengths of your study where you've taken care of threats to internal validity. You can talk about both of these things in the discussion section of your research proposal. Okay, so we reviewed internal validity checks that you need to make and suggesting that you fix these with an improved design. And or if they're unfixable, then you need to at least mention them in your discussion as being possible things that might get in the way of the validity of your study. Great, great, great. Next, we'll talk about external validity.